So now with the SD-WAN. Okay, so what are the things that we have to, first thing is, why we are actually going a bit deeper into SD-WAN is that these are newer technologies. Otherwise, if you just consider the design aspect of it, we can just do it maybe in a couple of hours, just the design aspect. But these are newer solutions, so we have to know about the components that actually make up the SD-WAN to get the whole designing aspect of it, the SD-WAN architecture. So why it is there, what are the things that need to be considered when you are designing it, right? So now, first thing is, what is SD-WAN? And why we require SD-WAN? So SD-WAN is just a SDN solution, where we are applying the same SDN concept, okay? SD-WAN is nothing but the same SDN concept that we are doing in the campus or in the data center or something. Now we are applying the same SDN concept where on the WAN network. That's what we are doing. Same SDN concept that we are doing on the campus, all the data center, we are applying on the WAN. That is, we are separating the control and the data plane, right? We are we have a single management point. So we have a single place where we can do the configuration, we can enforce the policy a lot more easier with SD-WAN solution over the traditional WAN. So just like the same features, benefits that you add up on the SDN solution can be defined as the benefits on SD-WAN as well. So some of the current challenges, why you will opt for SD-WAN network, while already you will have a network, WAN network of some sort, right? WAN network will be there of some sort. Now, why you want to adapt SD-WAN infrastructure? What are the reasons behind that? Is like, say, insufficient bandwidth is one of the main problems that might be there. So because you will typically have a WAN solution, which is your MPLS provider will be there. So you may have 1 Mbps, 2 Mbps lines, 10 Mbps lines may be there. So what happens that bandwidth may be insufficient because of the applications and everything, the bandwidth is insufficient. Maybe you want more bandwidth to be added. But if you go with more bandwidth, what will happen? The overall cost of the requirement will go much more higher, right? So I cannot just go and increase the bandwidth because it will increase the cost, right? So limited application awareness. The current technology, the current WAN network that we have has limited application awareness. So we are not doing application-based thing or something, or on the basis of application we are not seeing anything in the WAN, right? Everything is on the network basis, right? Network, subnet basis, prefix basis. We are forwarding the traffic from one side to another side, right? So there's no application part added into that. That means on the basis of application, we are not doing forwarding. We are not doing forwarding on the basis of application. We are doing more on the basis of subnet, the prefixes. Okay. So then you have downtime. So the current infrastructure has more application downtime, right? Because of the way you are managing your network, everything is in a standalone fashion. So if you want to apply any policy or anything in your network, you have to go step by step. So check over here, check over there, and do the configuration, right? Or even troubleshooting. When you want to troubleshoot, everything is per box management in a traditional network, WAN network. So that means there's no single place of management, single centralized visibility is not there. So definitely it will take comparatively more time to troubleshoot or fix the issue. So downtime is more comparatively in the traditional network. So fragmented security. So there's no security policy is not centralized. So there's no way to implement the policy in a centralized way. Centralized policy implementation is not there. So it's all distributed, fragmented. That means each and every site, we are applying policy, right? So the other thing is the current WAN infrastructure doesn't have any cloud readiness. Doesn't adapt to SD-WAN or infrastructure as a services or a cloud as a service, public cloud as a service. Those kind of things are not considered in the traditional WAN. So the other thing is the limited scalability that we can have and the high cost of deployment that we have, because if I want more bandwidth, I will add another line maybe. But if I add another line, cost is increased. Right? But even though I add another link, I cannot load share the traffic. Either this is my primary link and this is my backup link. right? It cannot be like both the links are load sharing the traffic or something. No, only one is the primary link. If something goes wrong with the primary link, the backup link can take over the traffic. Right? So even though you add more cost into that, the amount of return that you get from those things is not much. So that means complex operations are there, all that. That means these are some challenges that you have in your current infrastructure. Yeah. So what is generally a SD-WAN? Yeah. So it's the same concept of SDN taken into the WAN. That's what. Okay. SD-WAN is the story of applying SDN concept to the WAN. That's all. Nothing more than that. So there's nothing complex over here. So the same concept that you were using on the SDN solution, we are now applying to the WAN space. Right? It is a new user-friendly approach to centrally provision WAN edges. Right? So previously, traditionally, every device was managed on its own. Every WAN edge is managed on its own. But now with SD-WAN, I'm managing these devices from a central place, configuring them, monitoring them, reporting, troubleshooting. Everything is done from a centralized place with the SD-WAN. Yeah. So some of the three things that drives these SD-WAN are efficiency, experience, and security. This is one of the main factors that drives this SD-WAN solution. Efficiency. The SD-WAN solutions are more highly efficient than the traditional WAN because the way they implement the policies, they can do it in no time. I can, if I want to have some application requirements, business requirement is there, I can transform that requirement into the business, into the infrastructure, so I get return out of it instantaneously within no time. Whereas traditionally, it was taking more time to implement it. That means in order to get return out of that was delayed. Right? So then also it adds security. Configuration is also a lot more simple in the SD-WAN solution. So the efficiency, how it does it, by leveraging multiple transports available across different geographical regions. The other thing is, not only it gives you the flexibility of configuration from a single point, but the efficiency is by adding multiple transports across different geographical regions into a single kind of a logical network. That's what the main benefit is. Like I can leverage the internet and MPLS line. I can use internet as a WAN. So one of the main benefit, you can say, the major benefit of SD-WAN is, you can say, using internet as a WAN. This is one of the main benefit you can add up. Okay. The most important benefit is using internet as a WAN. Because if I use internet as a WAN, definitely I'm going to save lot of cost. Right, with by using internet as a WAN, because having internet line is a lot more cheaper than having MPLS line, and also the bandwidth on internet is comparatively much more higher than the MPLS. Right. The other thing is when I'm doing it, I'm doing it in a cheaper manner. So overall return on investment is much more higher. I'm doing load sharing, load balancing. The other thing is I will add up features of something like direct internet access. That means branches can now access the internet directly instead of them coming into the data center, right? Like hub and spoke fashion. Like all the traffic will come to the data center, then it will go out. Whereas now we can break the internet traffic at the branch itself. So this is one of the main point is you can use internet as a WAN, right? So application is also one of the things that you can do application-based forwarding or routing or load balancing. Or we can also use the term application-aware routing. This is one of the other benefit of SD-WAN. The security is strict control for audit, compliance, and mitigate existing and ongoing evolving threats. So easier to prove compliance over here, because without the administrative knowledge, nothing can happen over here. And you have full visibility from a single place. Whereas in the traditional network, yes, it was there, but you had to log into each and every device to validate it. But now you have a single visibility, single management point, and you can see everything, what is happening in the network. So you have full visibility across the network, easier to audit it, and easier to prove compliance with this solution. Okay, is that clear, guys? So what is an SD-WAN solution? So SD-WAN solution is basically the same concepts of SDN. I'm bringing into the WAN infrastructure. So that is like say with SDN solution, we have a single point of management So that's what we want. Same thing into the WAN as well. So we want a simple centralized point of management so that we get a single pane of management, visibility, everything can be seen from a single place. Not only from management, but also from policy implementation point of view. It should be single so that we can apply the policy seamlessly. The other thing is with any SDN solution is the logical policy is now centralized, right? So we can implement the policies in a much more easier way. So that's what we want. Same thing in the WAN as well. So you should be able to implement policies over the WAN network very easily depending on my business intent. So whatever is my business intent, I will take less time in order to convert my business intent into my configuration on the infrastructure with SD-WAN. Whereas with traditional network, it would take more time because you have to do a configuration on each and every device now across the network. Whereas with SD-WAN, it's a centralized point where you can implement the policies across the whole network. So there are three different things with SD-WAN gives you: efficiency, experience, and the security. With efficiency, so one of the thing is it gives you the transport independence, right? So that is one of the main thing is, if you go into any SDN solution, like say for example, if you go with SD access as well, even with SDA is as well as we have discussed till now, right? So what will happen with SDA? It's an overlay technology. We use overlays. So with overlays, what is required on the underlay? So we have the concept of overlay and the underlay technology. So underlay is independent, right? Independent of the overlay network. How it is independent? Because the edge and the border should just have IP reachability. That's what we require. Edge and the border node and the control plane nodes, they should all have the IP reachability. Now, they can be directly connected. They can have intermediate devices or something that's completely independent of the physical connectivity. I just require what? IP reachability between the edge nodes and the border nodes and the control plane. That means it is what? Topology independent. Topology independent, right? So just the same way your SD access network is topology independent, same way when you go with Cisco's in general any SD-WAN as well, but if you take Cisco specific SD-WAN solution as well, it is topology independent or transport independent, because we are thinking working on WAN solution, so it becomes transport independent. This is one of the main benefit of the WAN SD-WAN solution. That is, it is transport independent. That means we can have WAN, MPLS connections, we can have internet, we can have LTE connection as well. It is transport independent. That means even we can have WAN over the cellular network, over the LTE connection as well. Or we can have WAN connection over the internet, WAN over the MPLS. We can have it. With SD-WAN solution, it is transport independent. As long as we have IP reachability, it doesn't matter what type of transport you are using, right? That's the benefit of the SD-WAN solution. You can say the transport independence is another thing that you can add up with that. So there are main pillars with respect to Cisco's SD-WAN solution. So that is cloud delivered architecture. So the architecture is cloud supported. That means what we can integrate with deployments, cloud delivered services like application infrastructure as a service, IaaS, or a software as a service. So like say for example, I have Office 365. Right, Office 365 is a cloud delivered service, is a software based delivered software as a service from Microsoft. Right, so basically that every user that is sitting in the branch, if it wants to access any of the application under that Office 365 platform, he has to access the Microsoft data center, Microsoft cloud he has to access. Right, so basically your SD-WAN infrastructure, the Cisco's SD-WAN infrastructure is supportive of this cloud delivered architecture. That means we can create policies for this SaaS kind of applications, SaaS-based applications or infrastructure-based application, infrastructure as a service or software as a service kind of application, so that it is compatible with the cloud next generation models. Yeah. It is application and quality of experience is much more better with SD-WAN. How it is application and quality of experience? Because we have application and aware routing. Application aware routing as well as something called performance routing as well, you can say. Okay, application-aware routing, and also you can add something called performance-based routing. So because of that application-aware routing and performance-based routing, the overall quality of experience, user experience is a lot more better. That is, on the basis of application, we can select the transport. Okay, if the application is some XYZ application, use WAN. But if the application is some ABC, use both internet as well as the WAN to load share the traffic, right? So that we get better experience, right? So not only that, but it also keeps track of the performance of the links as well, like the latency, jitter, delay, all those parameters also your SD-WAN will monitor. So it will monitor the factors such as latency, delay, and jitter. So it will monitor these factors, latency, monitor, delay, and jitter factors to see the performance of the link. Like say I have two transports are there. One is the MPLS line I have, and I have the internet line. So basically, your SD-WAN solution will give the flexibility to monitor these links, internet links and the MPLS link, to monitor the latency, delay, and jitter for an application. On the basis of this delay, latency, and jitter, we can actually switch the traffic. We can use the links. Like say maybe the delay over here is much more higher, so we can use the automatically say, okay, if this traffic is coming for this application, use MPLS line, because there's more latency, delay, and jitter as of now. But once it gets fixed, maybe load share the traffic like that. So we can use the performance information or the characteristics of latency, delay, and jitter, the actual performance in real time. On the basis of that, we can switch over to the other available transport as well. So that kind of experience is there. So because of that, overall application and quality of experience for the users will be much more comparatively better over the traditional network. Okay, so which is in the traditional network, that kind of characteristics are not there. That is, you cannot do performance-based routing. It cannot be done in a traditional network. Whereas here in SD-WAN, those things are available. Not only application-aware routing, but also performance-based routing is also available. So because of that, the overall quality of experience for the users will be a lot more better. So comprehensive security, easier to prove compliance, end-to-end secure, right? So the other thing is it's agile operations. The operations in SD-WAN is much more flexible, much more uniform. It is easier to configure and easier to implement. Okay? So the WAN has changed, right? So how it is changed? So like say, for example, the users are connected to the branch. From the branch to the data center, we have a WAN connection, which is typically maybe the MPLS. Now, what has happened? So traditionally, we were doing that. So from the branch users, if they wanted to access the internet, so they were doing like that. But what was the issue was, with the traditional approach, you can say 80 to 90% of the traffic was focused to the data center. 80 to 90% of the traffic was focused mainly on the data center. That is, all your applications were in the data center. But nowadays, what is happening? The applications are moving to the cloud, right? So you have Office 365, right? Skype, WebEx, so many things are there. That means these applications are delivered as software as a service. That means many of the employees are now accessing these services on the internet. That means what? You can say more than 50, greater than 50% of the organization's traffic is in the internet. You can say again, like varies with vendors to vendor, customer to customer. Even some organizations can go 80 to 90% of the traffic is to the internet. Only like 10 to 20% is focused to the data center, right? So if you have something like that, why do you want to bring the traffic of the users, 80 to 90% of the traffic which you want to send to the internet, to the data center and send it? So why can't we break this traffic at the branch itself? If we break it at the branch itself, what will happen? The overall cost that you spend on the MPLS will minimize, right? So that is because the way our applications are there, it's changing, right? So because the WAN has changed, the applications have changed, the applications have moved away from the data center. So they are going into the cloud. They are going in the internet, right? So like SaaS-based applications. So because of that, even our WAN has to change as well. Okay. So now the branch users in today's world, what is happening? In today's world, the devices are there in a branch, so they will have, say, maybe MPLS connections and internet connections. So we want some kind of way that we can communicate these services via both MPLS as well as internet. It's not like only MPLS should be there or something. I can communicate to the data center via both internet or MPLS. This is what we want. I want for the flexibility, right? So I want both MPLS and internet. I want internet to be used as a WAN so that I get more bandwidth, more cost-effective solution, high availability it gives, resiliency it gives. If instead of just having one provider, I can now add internet as a provider, so and get more out of it, more benefit out of it. Deployment cost is lesser, but we get more return on the investment on the things that you're making. Yeah. So with this one, so what happens now? The branches are now able to access the services such as that are there in the multi-cloud environment, SaaS or the internet. The users can break out at the branch itself. They need not go to the data center, and from the data center they are breaking out. Traditionally, this was the case, but nowadays this is what we want. So the end users should be able to break out at the local branch itself. They should be able to reach to the internet. Traffic should not come to the data center. That means what? We are looking at some future such as direct internet access, DIA. Direct internet access for the users sitting in the branch. Okay, so from the branch, I can directly go to the internet. So without actually going to the data center, because of the application landscape, because of the changes of the application landscape, we have to do that. Whereas traditionally, because 80 to 90% of the traffic was going to the data center, it was making sense during that time. So to send maybe all the traffic over here, only 10% is going out. But now, if I send the traffic over here, more than 80% of the traffic, or 80-90% of the traffic, or even if you go to the smallest extent, close to 50% of the traffic is going to internet. So what happens? Why do you want to send that much of huge traffic to the data center? Right. So again, there is a lot of cost involved as well, right? With that, whatever things that you are doing, right? So there's cost involved. Overall return is not good, and also it's not efficient as well, because you are sending more traffic over here, so it's had to go back to the internet, break out at the internet, then come back again, right? So whereas if I have the branches have the internet access, they can break out here itself and they can communicate to the internet. They did not go to the data center and then get back the traffic. Okay, so that means it will make more sense to use to do breakout at the branches in today's world rather than at the data center. So we want direct internet access, and we want to use internet as well. So if I want to get both these features, so you want to add the security as well. If you want to make sure that whatever data is transferred, one of the main reasons why organizations don't use internet as a WAN is the security part of it, right? Is the security. That is not secure, right? So that's where with SD-WAN, not only it gives you the flexibility of using internet as a WAN, but also it makes it secure as well, because it uses IPsec. All the traffic that goes between these between these sites is encrypted by IPsec protocols. Is encrypted with IPsec, so that end-to-end traffic is completely secure, even though you are using the internet as a WAN, but it is completely encrypted, completely secure.